Hello. Hello and welcome to this video on date time formatting functions. So we had covered to section 9.9.1 and we will resume here. So we start with extract and date part. So the syntax is extract and parenthesis, you extract a field from some source. The extract function retrieves subfields. By the way, before we continue, there is a practical SQL file which I have shown in the previous video that will be done at the end. We will probably do that tomorrow or day after tomorrow because that's when this entire thing will be concluded. So probably tomorrow we will do it. So we continue our read through. The extract function retrieves subfields such as year or hour from date or time values. Source must be a value expression of type timestamp or comma date, time or interval. Timestamps and times can be with or without time zone. Field is an identifier or a string that selects what field to extract from the source value. Not all fields are valid for every input data type. For example, fields smaller than a day cannot be extracted from a date, while fields of a day or more cannot be extracted from a time. The extract function returns values of type numeric. The following are valid field names via century, which can be extracted from interval values, and the year field is divided by hundreds of this. So you see, we are extracting century from year 2000. So our century is 20. But if year is 2001, it is 21. For 0001, it is 1. And for BC, it becomes -1. And if interval is 2001 years, it is 20. Then we have day, the day of the month, 1 to 31. For interval values, the number of days. So here our day field is 16. Here we have 40 days. So result is 40. Decade is the year field divided by 10. So you divide it by 10. Our decade is 200. Then day of the week. Sunday is 0. Saturday is 6. So we extract 16. So 16 is 5 actually. Not really. 16 is not 5. It is the day of the week that would be 5. So it would be Friday. Note that extracts day of the week numbering differs from that of to_char and the function. The day of the year, 361 to 365 or 366. So here we extract the date of year from this year. So 31 days of January and 16 days of February is 47. Then we have epoch. Epoch is basically how many seconds have passed since 1st January 1970 midnight. For timestamp, it's time zone values the number of seconds since what I have said for date and timestamp. Without regard to time zone or daylight saving rules, for interval values the total number of seconds in the interval. So we have 16 February 2001, epoch is this much, and for timestamp, epoch is this much, and for interval 5 days and 3 hours, we have 442,800. We can convert an epoch value back to a timestamp with time zone with 2_timestamp. So you will give to timestamp the epoch argument that will be converted to date time value. Given that applying to_timestamp to an epoch extracted from a date or timestamp value could produce a misleading result, the result will effectively assume that the original value had been given in UTC, which might not be the case. Then we have hour field, which can be from 0 to 23. Here it will be 20. We have ISO date of week. So Monday becomes 1, Sunday becomes 7, and our 18th February becomes 7. This is identical to date of week except for Sunday. ISO year is the year matching year. Week numbering year, that the date falls in. So here 2006 becomes 2005. And for 2006, 2nd of January, it becomes 2006. The ISO 8601 week numbering year begins with the Monday of the week containing the 4th of January. So in early January or late December, The ISO year may be different from the Gregorian calendar. See the week field for more information. Then we have Julian, the Julian date corresponding to the date of timestamp. Timestamps that are not local midnight result is a fractional value. So we extract Julian from this date. So we have this timestamp, and for this we have this. Okay. For microseconds, extracts from the seconds part multiplied by 1 million. So it is 28.5, so 28 million, and we have 500,000. Millennium is the for interval values, the year field divided by 1000. So for 2001, it is 3, and when we divide 2000 years interval, then it is 2. Years in the 1900s are in the second millennium. The third millennium started January 1st, 2001. Milliseconds, the seconds field including the fractional parts multiplied by 1000. So here it becomes 28,500. Then we have minute, which is 0 to 59, so 38 is output. Then we have month from 1 to 12 for interval values, the number of months modulo 12. So here it is 2, and here it is 3, and here it is 1, because 13 months, 13 modulo 12 is 1. Then we have quarter is 1 to 4, so the month field is divided by 3 plus 1. So 2 divided by 3 plus 1 is 1, and here months divided by 4 plus 1, sorry, 1 divided by 3, so 2 plus 1, 3. Then we have seconds, so similar stuff, time zone. The time zone we offset from UTC measured in seconds, positive values compared to time zones east of UTC, negative values to zones west of UTC. Technically, PostgreSQL does not use UTC because milliseconds are not handled. Time zone underscore hour, the hour component of the time zone offset. Time zone minute, the minute component of the time zone offset. Week is the number of the ISO 8601 week numbering week of the year. By definition, ISO weeks start on Mondays, and the first week of the year contains January 4 of that year. In other words, the first Thursday of the year is in week 1 of that year. In the ISO week numbering system, it is possible for early January dates to be part of the 52nd or 53rd week of the previous year, and for late December dates to be part of the first week of the next year. For example, 1st January 2005 is part of the 53rd week of the year 2004, while 1st January 2006 is part of the 52nd week of the year 2005. 31st December 2012 is part of the first week of 2013. It is recommended to use the ISO year field together with week to get consistent results. For interval values, the week field is simply the number of integral days divided by 7. So we extract date here, and it is divided by 7. Then we extract week again, year 13 days divided by 7, that is 1. Here is the year field. Keep in mind there is no 0 ID, so subtracting DCF from ID should be done with care. When processing an interval value, the extract function produces field values that match the interpretation used by the interval output function. This can produce surprising results if one starts with a non-normalized interval representation. For example, select interval 80 minutes. So it is 1 hour 20 minutes, but if you extract minutes from the interval 80 minutes, then it is 20. When the input value is plus minus infinity, extract returns plus minus infinity for monotonically increasing fields like epoch, Julian, year, ISO, year, decade, century, and millennium for time inputs. Epoch, hour, day, year, decade, century, millennium for interval inputs. For other fields, null is returned. PostgreSQL versions before 9.6 return 0 for all cases of infinite input. The extract function is primarily intended for computational processing. For formatting date and time values, we have covered this, section 9.8. The date part function is modeled on the traditional index equivalent of the SQL standards. Function extract date part will give field and will give source. Note that here the field parameters needs to be string value, not a name. The valid field names for date part are the same as for extract. For historical videos, the date underscore part function returns value of type double precision. This can result in a loss of procedure in certain cases using extract is recommended instead. So here we extract day, we get 16. Here we extract hour, we get 4. Now we will look at date underscore trunc. It is conceptually similar to trunc function for numbers. The date trunc will take a field, source, and time zone. Time zone is optional. Source is a value expression of type timestamp. Timestamp is time zone or interval. Values of type date and time are passed automatically to timestamp or interval respectively. Field selects to which precision to truncate the input value. The return value is likewise of timestamp. Timestamp is time zone or interval, and it has all fields that are less significant than the selected one set to 0. So 1 for day and month. The valid values for field are microseconds, milliseconds, and so on. We already know the field. When the input value is of type timestamp with time zone, the truncation is performed with respect to a particular time zone. For example, truncation to date produces a value that is midnight in that zone. By default, truncation is done with respect to the current time zone settings. The optional time zone argument can be provided to specify a different time zone. The time zone name can be specified in any of the ways described in section 8.5.3. A time zone cannot be specified when processing timestamp without time zone or interval input, where these are always taken at source value. We have some example, and local time zone is America, New York. So we have this timestamp and we extract hour, or rather we truncate to hour, then the minutes and seconds become 0. Then we truncate year, so all other fields become 0 and month and year become 1. And similar examples are given. Then we have date underscore bin. It means the output timestamp into interval value aligned with the specified origin. So we have type source origin. Source is a value expression of type timestamp or timestamp with time zone. Values of type date are passed automatically to timestamp. Tied is a value expression of type interval. The return value is likewise of type timestamp with time zone, and it marks the beginning of the bin into which the source is placed. So here we have tied is 15 minutes, and this is our stuff. So here what it will do is, and the timestamp is this, okay? So two timestamps are given. It is the what we call source, and this one is origin. Okay. So here what happens? Output is this date, and it is brings to 15:30. Okay. So 15 minutes are subtracted here. And another example here. So here time zone is different. For the source timestamp, it is now given with the time zone with 2 hours 30 minutes. No, sorry, this is not time zone. This time is now contains hour, minutes, and seconds. So 2:30 is given, so that is our source, right? Origin. So accordingly, it is adjusted for 2 minutes 30 seconds. So this 30 becomes 32:30. In case of the full units, 1 minute, 1 hour, etc., it gives the same result as the analogous date underscore trunc call. But the difference is that date underscore bin can truncate to an arbitrary interval. The stride interval must be greater than 0 and cannot contain units of months or longer. Now we have at time zone and at local. The at time zone operator converts timestamp without time zone to or from timestamp with time zone and time with time zone values to different time zones. So we have several variations. So we have this first example, timestamp without time zone at time zone. It gives timestamp with time zone. So for example, we have a timestamp at time zone America Denver. It will be converted to that, and at local, so it is now doing local time zone. So this timestamp will be converted to this. Okay. So if you see, this is 17, so and this was 8. So 4 and 3, 9 odd hours of movement. Okay. Then we have timestamp is time zone at time zone. That's time zone. So we have this timestamp, and our time zone is America Denver. Okay, and this converted to Denver time zone. Timestamp is time zone at local, and similar stuff is going on here. So these are quite similar example. In these expressions, the desired time zone can be specified as a text value, example Los Angeles, or as an interval -8. And the text case time zone name can be specified in any of the way described in section 8.5.3. Interval case is only useful for zones that have fixed offsets from UTC, so it is not very common in practice. The syntax at local may be used as shorthand at time zone local, where local is the session's time zone value. So more examples are given, nothing complicated is here. So explanation of the output. The first example adds the time zone to a value that flags it and displays the value using the current time zone setting. The second example shifts the timestamp to time zone value to specify time zone and returns the value without the time zone. This allows storage and display of the values different from the current time zone settings. The third example converts Tokyo time to Chicago time. So, for example, this is the Tokyo to Chicago. Okay. The fourth example shifts the timestamp with time zone value to the time zone currently specified in the time zone settings and returns the value without a time zone. So fourth example is this. Okay, it is at -5 time zone, and then it is returned without time zone, that is the UTC. Okay, so not UTC. This is without time zone, right? For example, yeah, without time zone. And then we have -5, and it is also returned without time zone. Here, the time zone is modified to +5. You add so many hours. And similar stuff is going on. The sixth example, that is the last example. So we have this at local is a cautionary tale. Due to the fact that there is no date associated with the input value, the conversion is made using the current date of the session. Therefore, this static example may show a wrong result depending on the time of year it is viewed, because America Los Angeles observes daylight saving time. The function time zone timestamp is equivalent to SQL confirming construct timestamp at time zone. The function time zone time is equivalent to SQL confirming construct time at time zone. The function time zone timestamp is equivalent to SQL confirming construct timestamp at local. The function time zone time is equivalent to SQL confirming construct time at local. Then let's see how much we have. 2 pages. Oh, okay, we will do the last 2 pages tomorrow, and we'll look at the example. Okay, so I'll stop here, and I hope that you're finding this video useful. And if you have not watched previous videos in playlist, then you should go ahead and watch them. There are lots of examples on along with the theory. So with this, I will end this video here, and we will meet again tomorrow with the remaining part of the date time formatting functions and operators along with the example. So I'll take my leave here. You should keep learning and have a great day. Enjoy.